So
So students are discussing among themselves, whether they want
that's
to revise any particular topic or they just want to do some
no,
kind.
I mean if they are discussing, if they can like discuss and decide what they prefer to do, I would prefer that. Can give you some time anyway.
Yeah.
Then we can the process of importing for sure.
Yeah.
And then whatever they want. Otherwise, if
Yeah.
there's no consensus, we go over small of everything. Yeah. Sorry, Kavitha, you wanted to say something?
No, I was about to say that if somebody also wants to share their screen with the importing of data, we can also guide through or yeah,
Yeah.
anything in that direction. Yeah.
Would that work? And do you have enough?
Yeah,
Like,
the internet. Yeah. Or we could even think about just think about what your question is and go
Mm.
through the whole research process for one of your actual research questions and go through the hypothesis, all of these things that we learned yesterday. And I mean, there are lots of things, of course, everything can't be done in one day.
Yeah.
So that is one option. And another option is, say you have your variables and you have your data ready and things like that. We could also do what we did today. If you think you want to compare, you have an independent variable, dependent variable. Can you explain how can we interpret p-value for hypothesis?
Mm.
Uh,
You
of,
mean
from
like reading the p-value from a model, for example, and how how does that relate to the hypothesis testing we did yesterday? Yes.
I think you went over that this morning, right?
We can also
And
read
also a bit yesterday, I think we did that.
hypothesis, yes.
Yeah. Car model. Okay.
Okay. Then let me open my R.
I think the general rule for the p-value, which like we discussed yesterday, is that um, if it is lesser or equal to 0.05, then you reject the null hypothesis. And you then move on to saying that there is a difference or there is an effect of two variables um, or over one variable over the other and so on. Um, Maybe, yeah, we can, Cecilia can open up the uh, R code and we can
Yeah.
specifically look into this.
But I would actually maybe let's put everything together, like what Kavita said. Like we start from a question, we define the null hypothesis and the alternative hypothesis, then we define the variables, which one is dependent, independent, and then we see if might be some confounds, and then we do the model, and we in this case, we will have like the whole picture all together. How does that sound? I think
Yeah,
could, yeah.
yeah, yeah.
So let me see, because I am also, let's make two examples. One from the car data set and one from a different data set that it's completely new. So, and then we will also look at the import. If I forget, please remind me. Um, but yeah. All right. So let me share my screen again. I have a clean session. All right. Let me open the chat. Okay. So, let's have a look again at empty cars and we do a glimpse. Let's see what variables we can use for this. We need the library.
Yeah.
Libraries. Yes. All right.
So which variables are you interested in, Priyanka?
Let me think. We can just make. I'm thinking of a research question now.
The car
Just
one is like, yeah.
okay. So let's use this column. M is automatic or manual,
Okay.
and the where is the I think MPG
Yeah.
miles per. So okay, let's do this. Does the transmission type of transmission, so automatic or manual, which is the column AM, influence or affect a car fuel efficiency, which is the column MPG. So this is the research question. What we want to know from you, take your time, but think all of these things. We want to know, what is your null hypothesis? What is your alternate hypothesis? What are the X or independent EP, independent variable EV? And what is Y, the dependent variable?
Yeah.
I will also put it here in the screen, big screen, so
Can one of you type it out? Yes.
null hypothesis.
Automatic or manual has no influence, yeah,
No,
and may have positive or negative influence on what? On the MPG. Yeah, that's right.
exactly.
Yeah, that's right.
AM may have positive or positive or negative influence. But to be more precise, in this case, what is the actual hypothesis? Like, it's correct to say that could have any influence, but actually, usually in science, you'd give a direction as well. What is the direction of this influence? And is it positive or is it negative?
And is there also, like, I mean, you're right with the X and the Y, the factors. Is it like Cecilia said, is it a direct? Yeah. Is it a reverse? We also learned that today. And could there be a confounding factor? These are things that you can think about, like the DAG that we thought about, we learned today. All of those goes in this thinking process.
Exactly. So Priyanka says has a positive influence. So the type of um
Auto or yeah.
transmission has a positive influence on car efficiency. May have positive influence on fuel efficiency.
Yeah.
We choose this one.
Yeah. Or
And
mileage, like she said. Yeah.
exactly,
It's
mileage.
also a good, yeah.
Yeah. It's just that this MPG is miles per gallon, so it's also a measure of how much fuel it needs to do 1 mile. Yes. So there is a bit of confusion I see between the X and Y. Do we have a winner between what Kunal
Yeah, I
says and
think they
what says?
have said that. I think it's the
But
same. I
it's the
think
same.
Dheeraj has just switched the Y
Sorry.
and X.
Yes. Exactly. So the epsilon is MPG. We are
Mm.
agreeing on that. And the X is automatic or manual. Yes, we are both correct. I'm sorry, I just saw it opposite. All right. So now we have our hypothesis, we have our alternative hypothesis, we have our dependent, independent variable. We can do directly a linear model. All right. So our linear
What,
model,
so
yeah,
maybe someone can actually say what are we going to use for the linear model
yeah.
instead of
We can
because
also
this is a
do,
practice.
yeah, yeah. And actually, because we're doing like a overall practice round, remember the test we saw yesterday? What type of tests between a t-test or an ANOVA or a chi-squared, what kind of test could we use in this situation?
And before that, also look at the variables, like the two variables, what kind of data is there in these
Yes.
variables?
Are they
Oh,
categorical? Are
yeah.
they numerical?
Ordinal, yeah.
Ordinal? Yes. Let's have a look. And let's put it here. So,
Yeah.
and X is blank and Y is blank. I will put this a bit bigger so we can see
Yeah.
it.
Also discrete and continuous data, which like what kind of data sets are we, like what is the type of data? AM looks slightly different from the MPG that we are looking at. Like what
This
are
is a
these
trick test,
kinds
you
of
know?
data?
Yeah, this
And
is a
what
trick.
does, yeah, because this is confusing because it's not your X and Y are not the same kind of data, like data types,
Yes,
right?
yes.
So what is X and what, so you've already defined X as AM. So what kind of a data is AM?
Don't let, just as a hint, don't let this fool you. Yes, exactly. Super. Why? Because you see a number of a series of 0 and 1. So you assign to one of these two a value of 1. For example, it could be the manual, and the other one is 0. So if it's not manual, it's automatic. If it's
Yeah,
not heads, it's tail. If
yeah,
it's not success, it's a failure. Exactly.
mm, exactly.
Super. So we found that, oops, X is categorical and
Binary value as well. Yeah,
binary. Yes,
yeah.
we can also,
Binary, categorical. Yeah,
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 we could also change it into a factor, for example. And then there will be only two levels on this factor. There will be 0 and 1.
yeah.
And MBG is simple numerical, right?
Mm,
It can take
yeah.
any value and it's continuous.
Can-
Ah, sorry, I wanted to put it as a question, but the answer. So it's numerical and it's also a continuous variable,
Continuous. Yeah.
right? All right. So which test do we choose? Yay! The answer is there already. It's correct.
Yeah.
We choose the t-test because we are comparing the means of two groups, the automatic and
Yep.
the man, right? And we want to see, is there difference in mile per gallon in group automatic and in group manual? Should we
Yep.
do it? How do we do the t-test? So since it was from yesterday, could be that it's a bit not so in your mind anymore, but then let's do it together. The
Mhm. Could
function,
also
yeah,
look at the code from yesterday as well.
Yeah,
Yeah.
exactly. Open the code from yesterday. It's completely fine.
Yeah. But yesterday we had the data, like we created the data, like,
Mhm.
it was all shuffled for each one of us, but today we're all using the same this data. So again, we're using some things that we learned today, like, choosing the column, using the dollar sign from today, like using this empty car data, but then
Yeah,
eventually we'd be using what we did with the t-test yesterday.
yeah. All right. So
Mhm.
from yesterday, the code it's very similar to the one we saw today, actually, from the
Yeah.
linear model. It's
Yeah.
identical, right? MPG, IM,
Mhm.
data, MT, cars. So once again, we have this result. What do we look at? What are our four main things we want to look at? One is the p-value, and it's very small. It's very well below our cutoff of 0.05. What does it mean? What do we do when the p-value is below 0.05? Somebody type it in the chat.
Yes.
We reject. We reject what?
Reject the what?
The null
Exactly.
hypothesis. Yes.
Yes.
Super.
Yes.
Super.
Nice.
And the null hypothesis was, let's go back to read it, that AM has no influence in PG. We reject this hypothesis. We know now that it does, because the p-value is very small. The other thing we want to look at is the difference between the group means, all right?
Yeah.
Because that's
Yeah.
what the t-test does. The average for, um, what is it? Here it is, sorry. The average for group 0, which
Likely
actually
to be
automatic, yeah.
or
It,
manual, no? Okay.
I think the 0 means automatic, I think,
Okay.
because
Okay.
that's
I
the
mean,
more common. We can also look it up, because yeah, this is something you would want to know in this case, because yeah, would have been better if there was a and an M. Instead,
yeah.
with 0 and 1, it's a bit
Yeah.
tricky.
Yeah. Yep.
But let's assume that the 0 is the
Yeah.
automatic. And the mean is 17, while the mean for the other group is 24. So we have the average mean for each group. This is great. And we also have the confidence interval. What does the confidence interval say in this case? The sentence we tell ourselves starts with, we are 95% confident that yes, exactly. The t-value falls between these two values of the confidence interval. And that the group 1 gets more miles done than group B. Or let's say that the manual cars, group 0, gets between 3 and 11 more miles than automatic cars. Okay, and this doesn't encompass 0, so the relationship is truly in one direction. Okay, now let's make a model as well. Oh, I'm not typing. Typing in the right one here. All right, how do we make a model in this case? We create a variable model.
R.
What do we put? It's very easy, very similar, actually identical to the one we had above. And we do mpg time data and tcars. Just like this, we won't have all the information we need, so we will do summary. What does it say? We have a very small p-value in this linear model, so it's quite significant, but sadly, that's not the only thing, right? So it explains some of the variation of our data, but not that much, which is expected. If I have a car that it's very, it's consuming a lot of benzene, how is it called? Fuel. I don't expect only the type of transmission to be the only thing that has an influence. It could be one of the things that might have an influence in my fuel consumption. So it is very significant, but it's not the only variable that can influence our mile per gallon. So what could we do in this case? We could have a glimpse again and say, okay, out of all of these values, what could also influence the miles per gallon? What could be the variables here that could influence how much my car consumes? Horsepower, weight, yeah. There's also this one, I think it's carburetor. I don't know, was that influence? I'm not sure. I don't know much about cars, so for me, any guess is a good guess, but we could try.
Okay, we can try horsepower. Yeah.
Let's do another model cars too, in which we know that AM is influencing, so we keep it, but we add, what do we add? Horsepower. And we also let's add also weight, which was WT.
And also cylinder, because there's one
And
more
also,
as well.
let's see what happens.
I mean, the three, yeah.
And then data is my MT cars. Summary of model cars 2. What happened now? Wow! It's beautiful, but look at what happened. This is very, very interesting, actually. Among all of these variables, actually, now the one we had at the beginning is the one that has no effect, right? Is p-value, it's so high. Why? Because among this other one that we included, there are some that have way more influence. So probably our automatic manual question, that was a confound. Sorry, there was a confounding variable that was masking the relationship between the two, right? So if you had to make a diagram about this, before you had, it was exactly like the ice cream and shark attacks. And you thought, well, these two have relationship, but actually there was something else, a confounding variable that had an effect, a stronger effect on the miles per gallon. And this one would be which one of the variables you suggested? Which one is the strongest and the second strongest effect? you can see it from this output.
You can, yes.
Yes, this is the first, exactly. So, because you can see exactly this as the strongest, there's two stars, and you can see it here, 0.08.
008, yeah.
008, yes, thank you.
Yeah. And yeah, HP
HP
is the
is the
second.
second. Exactly. Cylinder, not really, but actually between cylinder and type of transmission, like type of transmission is the one that does the worst. And this model now explains like, wow, 84% of the variance of our data. So now we are very confident that this is the best model because, wow, we have two coefficients that influence our dependent variable, and all of this model explains most of the variation of this data. Should we make another example with another data set, or do you want to investigate something more on
Is
this?
your question also answered, Priyanka, or do you have another question to add to that? Okay.
Same data, same code. Let me see. Formula, MPG. Yes, it is. And you, oh, wait.
Yeah,
Oh,
it's different.
empty cars. MPG. You have horsepower twice.
Mm.
Try to remove one of the two horsepowers and see if the output is the same. You are missing weight and you have horsepower twice. That's why. Then, yeah,
Yeah.
it's interesting because once you remove weight, the type of transmission suddenly have more significance.
Yeah.
Should we try to plot it, for example?
Yeah.
Let's
Oh, it's
see.
still.
Now you don't have weight still. You
Yep.
have so before you have two horsepower but no weight, and now you don't have still the weight. So the model is correct. The reason why it's different from the one in the big screen is because there is one variable different. Yeah, one less. But it's also very interesting. Like without
Yeah. Wait.
this, so 80% is quite, yeah.
Yep. Nice.
No problem. Actually, it's a good exercise and a good
Yeah.
practice.
It's also interesting. I mean, without the weight, you do have a significance with the transmission, the automatic and the manual, and also a bigger significance with the horsepower, like your second photo that you've shared. Yeah. I mean, it's just that when you're looking at variables, like, when you're considering certain variables and you don't have another variable, of course, like some other significances do pop up. So here you're considering only the the transmission, automatic or manual, the horsepower and the cylinder. But like, yeah, once you add another variable, yeah, change, like, the parameters change a bit.
All right. So let's try to plot this simple model here. So how do we do it? We do ggplot. We give it the right data set. We give it the static. Our x is am. Our epsilon is mpg. And our data, we put it already. Perfect. And then we do a geom point and we give it a color. Why not? And we need, color. I always like to put colors in plots. You don't have to, it will work anyway without. Geom point smooth then, right? The method is lm. And we do a color of sea green. And we keep the standard error, so we see the gray area. Let's see. Oops, it's not geom point written like this, but there's an underscore. And let me wipe this up. Ha! This is one of the examples we had before, right? So, it could be that the geom point is not the best visualization in this case. What could be a visualization that we did yesterday, for example, when we have categorical variable like this? We have a 0 and we have a 1. We don't need all the ones in between, right? Because, yeah. What could we do instead of the points? What's better? What could be better? It's not necessarily, but... So yesterday we saw that for categorical variables, we use the box plot. So instead of these points, what we can do is to change this line. I will comment it. And we can put a geom box plot. We can just keep it like this. We keep the line because we can see the direction of this linearity. Oops. What happened? Wait. I know what happened. What do you think? It's something that has to do with how the data is organized. So we know that the automatic and the manual, the 0 and the 1s are factor. We know that, but R doesn't know that. It thinks that there are numbers. You can see it here. It thinks that these are all numbers. So what we need to do is that we need to tell R that this is actually a factor. How we can do that? Maybe, for example, I don't want to change the data, but I want to plot it. So I can just say that in the plot, treat this as a factor. All right? So if we try again, magic happened, and now we can see that, now that you told me that these are factor, I can then do the two different plots. All right? The line actually you can't see with this visualization. So yeah, we can keep the points in this case to see the, oh, why did it go? No, what is it? Yeah, if I remove the factor now, should be yes.
I think it's also a good place to understand like where we can use scatter plots and box plots, like what kind of data. I mean, of course, we didn't go deeply into visualization and plotting, of course, but
Hmm.
I think it's a good place to also see that, like, yeah, looking at this as a scatter plot really doesn't help, but a box plot does
Yes,
to show the
yes.
variance and all that. And I just found this
Mm-hmm.
and just put it in the chat. I think this is a good website to look at all the different kind of like
Oh,
charts and the graphs that you
yeah.
can choose for your like the kind of data that you have, and it also gives you a good explanation in your like for the future um, as to which chart you could ideally use for your data set.
Mm-hmm. Oh, this is a super website. I will save it.
Mm.
All right. Let's do another example, maybe with a different set of data. So for this example, we will use a new data set. And this data set is called Palmer penguins. That should have become base R recently, but just in case, I want you to try to type library Palmer penguins. Attach embed. I think it's within R already. So you shouldn't be Palmer penguins. So just try. If it doesn't work, you just run install packages. It's called Palmer penguins. All right? Let me know if it runs. We have it. Perfect. Okay, let's have a look. Glimpse, Palmer, penguins. Oops. Mm, we need to save it, I think, first. I think we need to save it as an object first. It's not. I think I saw somewhere that it
We
became
did
R.
we did we call the
Hmm?
library yet?
Yes, yes.
Okay. Then
I because I think I saw a message some time ago that it became included, but maybe I'm wrong. I thought it was the same as empty cars, but doesn't matter. Um, so what we can do, no, maybe it's like this. Palmer penguins. Sorry, it's like this. Okay, the notation is this. So within the package, Palmer penguins, take the dataset penguins. This is the notation I was looking for. So if we put this as a glimpse, oops, should work, yes. So this notation is just when you put the name of the package first, then you can select with this two semicolon the what you need from within that package. And in this case, we want the dataset Palmer penguins. So in this case, if you run the glimpse, you can see these are data from penguins, actual penguins. So what kind of data do we have? We have the name of the species, which is a factor. We name the name of the island where they are, the bill length, so of the bill, the depth, and the flipper length, so the arms, body mass in grams, sex, and year. My research question to you is this. So we do exactly the same as we did before. I give you a question. We identify null hypothesis, alternative hypothesis, dependent variable, independent. Is there a significant difference between in body mass, which is body mass grams, between Adelie and Gento penguins? Question mark. I want null hypothesis, alternative hypothesis, depending variable, independent variable, and which kind of test would we use in this situation between t-test, ANOVA, and chi-square? So what is the H1, X, and oops, I forgot why. There is no difference between the two species. Perfect. There are differences. I want it to be more precise. You can make whatever statement you want, but let's just as an example. Actually, maybe before making any statement, we could plot it, for example, and see actually what is in which direction is the difference, right? And body mass and the type of penguin, yes. Which kind of test would we do in this specific research question situation? Exactly. But let's say that before doing anything, actually, I want to have a look at this data set because, don't know if you noticed, but I gave you two names of these penguins, Adelie and Gento, that those are the ones I remember. But let's have a look at this data set. I want to see how many different species are within this data set. How do I do that? The function is unique, and then the data set is penguins, $species. This, if I run this code, it tells me that actually there are 3 different species in this data set. The last one, the chinstrap, I forgot about, but yes. So actually, why are we only comparing these 2? Let's change our research question is there difference between Adelie, Gento, and chinstrap penguins? Yeah, super fast. Wow. Nice. Then it will be ANOVA. So everything else can remain the same. Our hypothesis is the null hypothesis is still the same. The alternative hypothesis is still the same. Body mass, type of penguin, all the dependent and independent variables are the same. We just change the type of test. Why? because we moved from 2 groups to 3 groups. All right? So, what do we do now? We can do directly an ANOVA, for example. Or we could also just plot it first. Maybe we can see. Let's do a ggplot. We use the penguins. We give the aesthetic of x equal the species, y the body mass, and we want to fill by species. Oops, wait, we need more space, otherwise I don't see anything. And then since I want to see the difference in means between 3 categories, actually box plot is the best option for me at this point. And that's it. So if I plot this, what would I see? That somehow 2 of these pieces are more similar to each other and the third one is a bit different, right? So now I could do an ANOVA. How was the code for the ANOVA? So this will be the name. How do I name my thing, my model? And the code was AOV, body mass, G, species, in which the data is the penguins data. Right? Once again, we have to run the summary of penguin. Oops, penguin. And what do we see from this summary? The p-value is very small. So what do we say?
That,
That we reject what?
yes, that there is a difference
Mm-hmm.
between the
Yeah,
body
there is.
masses.
Yes, super.
But what would your statement be then? There's a difference between the body masses of the different types of penguin. That's your like it's a very generic statement then, because you are not really comparing Adelie versus Gentoo and Adelie or versus Chinstrap. It's like just within the different types of penguins, from the types that you have compared, there is a difference. That is
Yeah,
the main understanding, because you haven't done the pairwise comparisons.
yeah, exactly. So we can try now to do the linear model once again, and we will have similar results. Oops, sorry. So penguins LM, I will call it, and it will be LM, body mass, what is it? Body mass G is called, right? Yes, and species data penguins. and summary of penguins LM. Once again, so this is exactly what Kavitha was saying. So the ANOVA doesn't really tell us what's the difference with whom, between whom and whom, right? And we see from the plot that there's at least two are not so different from each other. And actually by using the linear model, what happens here? It happens that R chooses one of the species as a baseline. And you can see it because it's not represented here. So which species is missing? The Adelie species. Usually R uses as a baseline alphabetically, the first one that comes is always the baseline. It chooses just the first in the data set. So unless you assign which one you want as the baseline, it will just choose the first. In this case, Adelie alphabetically comes first. So R chooses that as the baseline. So what can we say from this output that we could already see, for example, from the plot? Who is different from whom and what is the p-value of that difference? So, yes, so species Gendo is significantly different from Adelie. And on the other side, the species Chinstrap is non-significantly different from Adelie because the p-value is so high that we keep the null hypothesis. What was the null hypothesis? Is that there are no difference between the species. And for species Chinstrap, we can say that with confidence. And yes, the model explanatory power is only is relative, all right? Don't be too strict on this. Sometimes 66% is okay, is enough. Sometimes it's not enough. Sometimes it's the best you can do. It always depends on the type of model and the type of data you have. So yeah, it is 66%. That it's something that it could be enough as if you explain it in your discussion part of your paper or if you're in your discussion, you say, okay, this is once you do different models with other type of variable, you get the one that you prefer and then you explain why you chose that model. Yes. Super. Good. All right. So what else can we do? I'm looking at my list of exercises. Let's keep this data set and maybe let's ask another question from the same. So let's glimpse at it again. There are other variables here. For example, the flipper length could be something we can investigate. So, for example, in biology, most of the time we say that the size of one body part is you can predict the overall size of the animal from that body part. In humans, could be the length of the leg, for example. it's quite, or the length of the arm, for example, it's quite often true that the longer your arm or your leg is, the bigger the size. All right. So in animals, including humans, we use sometimes, I think in humans, we use the leg of the femur, so the bone of your within your thigh, and yeah, but in general is common, usually common in biology. So what we could do is to see does the length of the flipper, which is the arm of the penguin, influence body mass. So maybe we can give you 5 to 10 minutes, and the question is, does flipper length, oops, I wanted to write it in the chat here. Does the flipper length influences body mass? So once again, we want hypothesis, null, hypothesis, alternative, X, Y, and then you will decide what kind of test to use, which test, and you will run it in your R, and then you will do a simple linear model. All right? 5 to 10 minutes, and then you give me thumbs, and you can also recopy, repurpose the code you already wrote so far. And then you can either paste the code in the chat and tell us how you're doing. Let's also do 10 minutes of this exercise, and then maybe let's take a 5 minutes break before wrapping up.
I think we'd have some answers with what is a null hypothesis and alternative and what X and Y are. That's correct.
Yes.
And maybe we can try this code.
Yes, yes, yes. Model. So if you don't mind, I will just copy your code here and put it in here. So model flip body mass, linear model, body mass grams, and flipper length. Data penguins. So
maybe you can, I'm just writing that on the chat, sorry. I was just saying that, like, yeah, you gave the code and then I'm sure you got the results, and sure Chechi is going to show the results. Yeah, but like, can you maybe say what, like, what you read from the, like, you know, the result, the output? What is your answer to the, so what happens to your null hypothesis and alternative hypothesis? And what does your plot show? Like the code is fine, like it's okay.
Yes.
Okay, and how do you see it?
Okay, the check down receive positive influence
And
because
what is significant?
hmm,
Yes. So what has an effect on what then?
this is very important because it's really important to make you think, what was my research question? What did I just made a model of? Do I reject the null hypothesis? What does that mean? What is significant on what? It's a very good exercise.
Mhm.
All right. Yes. So
Yes.
a slightly more precise way to say the same thing would be flipper length is does influence positively influence, right? In which direction? Like the more the flipper length goes up, the more the body mass goes up.
Mm-hmm.
Positively,
Mm-hmm.
yes.
Exactly.
And yeah.
Yep. Okay.
All right. So, any other question? I will stop sharing my screen now because
I
then
think that
we
was maybe before you stop
can...
sharing it. I just thought about it now because there was a question of importing data,
Yes,
and maybe you can just show on the screen where you could do that.
absolutely. Let's do that. Let me reshare quickly. Thank you for reminding me because, of course, I forgot about that.
And if you
Uh,
have any other final questions as we do that, maybe please share that in the chat so we can, satisfy your
yeah.
questions.
Mm. I'm checking what data can I load. I'm just looking for some
Mm,
local data I have here.
mm. You can also maybe think of sharing something that I
So
have.
let me open a new script. Okay. So one way to do this. So first a question. You guys have learned in the past few days how to use R. Did you talk about R projects and the importance of what is a R project? Or yes, perfect. So what I will do now is to open a project in my R studio. I have a recent project from my own research. No, actually not, because this session is recorded. It's not. Yes, this is published already, so I can show you the data from this. The other data is not published yet, so better not yet. I have to upload it all online first. But anyway, so don't look at all this mess. It's not important. What's important to know is that here I am within an R project that I called OD Learning, which means
Oh,
like,
Chichi, we
uh,
don't see your screen or anything yet.
thank you. Okay. Okay. I just opened an RStudio project, and it's called OD Learning, which literally means Other Discrimination Learning. It's a test I made with some animals, but none of this is important. We are just looking at the project, and we can see that we are within this folder called data, and inside this folder data, there is another folder called OD Learning. And within this folder, I have some script. That one you can see it's open here. It's called associative learning. It's something I am investigating in this data set. But of course, I had collected data in a Excel file, which for me it had an extension of CSV. All right, so what I did in this case, I loaded my own CSV file with this function called read CSV that imports the file with like the direction, like where is this file is inside the folder data, inside the folder data, inside the folder OD learning, and it is called associative learning.csv that you can see here. All right. I could run this only like this. This would be enough to load this data set. But I also added some additional information. For example, in this data set, if I view the file here, you can see that the first row is the column name. So there is ID, there is sex, there is season, status, and blah, blah, blah. And these are all my columns. So what I can tell R is to keep this column as the header. So the first row you count as the column header. So when I import this data set, I can have that. And the separation is because each value in this data set is separated by a comma. So I tell it, and the decimal number is dot. And I want, if it finds that there's some missing data, instead of keeping it empty, I want it to say NA. So this is how I will load my data set. And if I load it, it's already here. And as you can see, I have all my columns. And then I can do my tidyverse tidying of the data. And if I do all data, I say season, this is one of my columns, and I can say it's a factor. It has two levels, and those levels are summer and winter. Super.
Cool.
You all right?
Okay.
So I think we did it successfully. So, so
Yeah.
great. So I guess with this, all students present here and all three instructors present here. So let's announce the closing of this, 5 days second SARA Statistics Winter School. So congratulations to three instructors, we all three, and all the students. So thank you
Yeah.
so much for all this kind cooperation, and thank you so much for waking up 5 a.m. in the morning and taking the sessions. That's a huge respect and huge dedication. So from all of us. So
Thank you so much for being here
Thank
today.
you.
and
Yeah,
after
thanks
this,
for
we have
that.
around like an hour, and we are going to have a small closing ceremony here. So, if you guests will be arrived, uh,
Mm.
and will be sadly we do not have a hybrid system, so we can share the live event, but we'll share the pictures and the videos later on with you, definitely.
Yes.
And
Yes.
on behalf of SARA team, Dr. Kiran ma'am, my daughter, my mom, everyone, we say thank you to you because we together taking baby steps and helping SARA Institute to grow. We are very young institute. This is our third year only, but we are trying our best, to help especially marginalized communities and women to come
Mm.
into the STEM, where actually
Yes.
the more power is and you can do really effective decision making research. So and I'm very happy at every step. I'm getting a lot of support, and So I'm very happy we connecting first time with Dr. Kavitha as well. Yes, and
Yeah.
definitely we connect more and we learn more together.
Great.
So with your permission, so let's end this session now. It's
Yeah.
Okay.
Sure.
So have a great day ahead and see you
Thanks.
soon.
Yeah.
Thank you.
Yeah.
Bye.
Bye bye.
See you
Thank
soon. Good
you.
luck.
Thank you. Yeah. Good luck.
Thank you. Thank you.
Bye. Mhm.